right now is I want to go through an example. So this example is going to come from our homework. So so how long is a radio frequency? Oh, sorry, how long is a radio wave with frequency? Is a radio wave. I'm not going to write out the whole thing. I'm just going to write out the question. How long is a radio wave? And here I'm going to put my information. Frequency and how fast do light waves travel? They travel at the speed of light. So my speed is 3 times 10 to the 8 meters per second. Okay, and my frequency here is, I think I'm going to try 12 megahertz, which is equal to 12 times 10 to the 6 hertz. Okay. So if I know the frequency of my wave and the speed of my wave, can I find how long it is? So here, what I'm looking for is wavelength. What is it? So I'm going to give you guys a little bit of time to try this out. Okay. Try this out and see if you can find how long a radio wave is. I'll give you guys about 30 seconds. So sorry, we'll do like a minute and then we'll work this out together. So all I'm going to do is I'm just going to set up the formulas. So you guys keep working. So just like we do it in class, you guys keep working. I'm just going to set up the formula here. Oops. Okay, guys, so let's go and do this together. So like I said, getting into the end of the course here, the problems are much simpler. These are just some tools for us to describe different kinds of motion. This is wave motion, right? So what we're going to do is we're going to solve this. I want to find what is my wavelength? How long is a radio wave? So radio waves, this is actually physically, right, a radio wave. So when it travels at the speed of light. It's an electromagnetic wave. So all light travels at the speed of light, which is 3 times 10 to the 8 meters per second, okay? Or 300 million meters every second. And I know like a radio station, right? And when you do like a radio station, you have like 87 point something, something like that, right? All of these, they're in megahertz for FM stations. So I think they're in megahertz. Uh, so let's say they're megahertz. So I want to know how long is that wave actually? So when it comes in, into my car, right? If I'm listening to a little radio, so if this guy here, if he's got a little radio, that's a radio antenna, okay? How long is the radio wave that's coming in, right? So how long is this wave? So to find this out, all we're going to do here is we are going to plug in our value for frequency, for speed, and get wavelength. So let's go ahead and do that. So I want to know what my wavelength is, so I'm going to divide both sides by f, right? And I'll have wavelength equal to speed over frequency. Great. Now we just plug in our numbers. This is 3 times 10 to the 8 meters per second divided by 12 times 10 to the 6th hertz. This should give us, I think I just did this in my calculator, if I did this right, should be 25. So this is 25 meters, okay? 25 meters. So this radio wave is pretty long here, right? This radio wave is super long. So you'll probably get a little bit shorter of wavelength than I did because for your homework questions, what I've done is I went ahead and used actual radio, like, radio station wavelengths. So when you do this, you're going to get a little bit lower number. I think when you do this for radio waves, they should be like on the order of a few meters, Um, so here, this is 25 meters long. This is about 75 feet long. This is how long one wavelength is, right? So it's super, super long. Um, we're not going to get into how exactly this helps radio waves transmit or anything like that. But just know that it's just a wave that's really, really long. Okay. Next, I want to talk about here, we say part 3, standing waves on a string. All right, so we're actually going to do this lab next week. Um, but what we're going to do today is I want to talk to you about standing waves on a string. So let's say I have, you know what? Let's say I have a string and let's say it's attached at both ends. It's kind of flexed at both ends. What will happen is if you pull this string tight, right? And then you kind of run your finger over it and pluck it, right? What will happen is this string right here will start to oscillate, right? So it'll start to oscillate. You know what? I'm just going to put one wave on it to make it easier. You can, you know, have it with two waves, but I'm just going to make it one wave, make this super easy. And when this happens, this wave will actually oscillate up and down on both sides, right? So when you look at a string that's actually vibrating like this, you probably see something like this. Up and down, up and down, right? So it'll look something like this. So what we want to do today is we want to talk about this. Um, and the best way that I've always used to think about standing waves on a string is in a guitar. So I'm going to draw a guitar here. Okay, hold on, I got this. Right, so I need like a, uh-huh, yep, and then this thing. Good. No, that's not right. And it should have like a little thing like that at the end. Huh? Right? And then there's like a hole in the guitar. All right, so that's our guitar. This is great. So our guitar here is going to be the simplest case. Okay, the simplest case in that um, it only has one string. Okay, so it only has one string, and uh, that's it. So all we're going to do is we're going to look at what are the different parts of this, what affect the note that comes out when we play this thing. So this is kind of big. I'll make this a little bit smaller. So the first thing here is I want to talk about the frequency. The frequency is going to be the note that you hear. Okay? This is the note that this string plays. Right? So we have a formula for this, but I want to build it with you right now. I want to see what are the different parts of um, that affect the frequency, what affects the note that this string plays, right? So if I have my string here, my one string on my one guitar, does that mean I can only play one note? So I think not, right? So is there a way, even if I only have one string on the guitar, is there a way to change what note will come out when I strum this string, right? So what I want you guys to do is you can go ahead and you can either, of course, you can always shout out the answer, but always you can type in the chat if you know a way that I could change the note, right, with this guitar string right here. So let's say right now my guitar string plays a C, and I want to know if it can play like an A or go up to like a D, something like that, right? So can I change the note if I only have one string on my guitar? So if you can, how would you do it? How would you change the note? Ah, so go ahead. Anybody think of something? Uh, any suggestions on the way we can change this? Does it depend on what part of the string you play? So I don't think so. Okay, yeah. So does it depend on what part of the string I play? Actually, that's a really good question. Uh, if I, good, I've got some good suggestions. So if I have a string here and I play right here versus right here, you actually see that the same note comes out. If you just leave it the way it is, it doesn't matter if you pluck the string of a guitar like up here or like down here, it'll play the same note, right? But kind of getting to what this actually is, I have two suggestions here. One is, what if I press down on this string, right? So let's do this. Okay. What if I put my hand, oh no, like right here. So what if I put my hand right here? Then what will happen to the note is you've probably seen people play guitar. You know what? They don't play it like that. They put the hand like from the bottom, right? So if you do this, then the note will go up, right? It'll make a higher sound. If you kind of choke up on this string here and push down on it, then what's going to happen is the note that it plays is going to be higher, right? The frequency is going to go up if you do this. So what's actually happening? When we do this, okay, so let's go as number one, press down on string. So when you do this, okay, initially, this is my original. This is my original string. And then what's going to happen when you put your hand down, like when you put your hand right here, this whole part of the string that's on the other side of your hand doesn't vibrate anymore, right? Only this part still can vibrate, right? So now it does matter kind of where you play. If you strum this part, that would be weird. But like if you did this, it wouldn't make the same note as if you strummed over here, because your fingers are in the middle here. They're separated. You're making two strings with your hands. So what you're going to do is the new string. Oops. Let's say this is new string. So when you play this, originally we had this wave. Let me go and do that again, not so messy. Okay, now, there it is. That's my wave. So what has happened to my wave is I've made my wave shorter. Okay, so this is wavelength is shorter. Okay, so now we've established that if I make my string shorter, if I make my wavelength smaller, my frequency goes up. That means they're inversely proportional to each other, right? So let's go ahead and, or sorry, not equals, proportional. I'm gonna leave it like this. We're just looking at the relationship between these things. So my wavelength should go on the bottom, because if my wavelength gets bigger, this whole number will get smaller. If my wavelength gets smaller, this whole number will get bigger, right? So wavelength should be on the bottom of our formula. Okay, next thing, if we make the string tighter, this is super good right here. Let's go do this in green. And we're going to say number two, tighten the string. Okay, so if we tighten the string, okay, usually you do that up here. There's like little things to do that, right? Let's say this one is connected to right here. And then there's like a little thing and you twist it, right? You twist it, and what happens is it actually tightens the string. And when it tightens it, the tighter it is, the higher the note will be. The same thing. If you tighten this, okay, then the string, the note that you play will go up, right? So you probably heard this, the ten, 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 like if you're kind of tightening this string, the note that's going to come out. So this is tension, right? We talked about tension. It's the force on a string. Tension increases. So if we do this, my force of tension should be on the top, because if my tension goes up, if I make this string tighter, the frequency also goes up. The note that it plays gets higher, right? So these should be directly proportional to each other. So this is good. There is one more thing. This is actually now the limitation of our guitar, right? But this is true for any guitar string. So what does it matter? What's the difference if I put another string here? What does it matter? If they're the same length, then what's the difference between these two strings? that this string will always, almost always play a much higher note than this string. And it's not related to how tight they are. Okay, what can you think of? If I have three strings here, this one like this, and I'll go ahead and get rid of this guy. So I have three strings. One plays a low note, a medium note, and a high note. Let's say they're all the same tension. So they're all tightened the same. How can this one play a very low note and this one play a very high note? If you've ever seen a guitar, what's the difference between these two strings? What do you guys think? So go ahead and let me know. Anything that you think is the difference between strings, but here, the last way, I'm going to go ahead and start writing it out. This is going to be, so go ahead and think about it and leave any suggestions in the comments. So what is the difference between strings that makes some strings play very low notes, some strings play very high notes here? Okay, very nice. Okay, Naomi, good. So here, number 3 is going to be change the string, and it's very good. If we look at this, this is actually thickness. So if I change the thickness of the string, if I have a thicker string, right? So let's go ahead and see if I can mess with this. Nope. All right, never mind. So thought I could get one without getting the other. Um, so here, what we're going to have, probably do it like this. I have a thick string, right? And then a medium string, and then here, last one will be a very thin string. So all we're doing here is we're changing our string thickness. And when we do this, so just if you guys haven't noticed already, this is very fun for me. So sorry if I'm just messing around and you guys want to get to the lesson. I know you want to get to the physics, but this is very fun. I highly recommend everyone playing with this. Okay, so um, last thing is if I increase string thickness, so here I can say thicker strings play lower frequencies. Okay, if it's thicker, my my frequency goes down. So that means if my thickness goes up, my frequency goes down. These things are opposite. They're inversely proportional to each other. So the last thing here is that my string thickness here. So if I were to put on the bottom thickness, okay, then our formula would be done, right? But thickness is pretty long. I don't want to be writing this over and over. So the way I'm going to express this is going to be by calling this linear density, okay? Linear density is a fancy M. I'll put it here. Or you know what? Linear density. It just means my string is more dense, right? It's more dense, it's heavier. It actually doesn't matter if it's thicker. What matters is that it's heavier, right? Each section of it, if I take an inch of that string and an inch of another string, one string is heavier than the other string, right? So my linear density. So here it is. These are our three parts. So if we kind of put all of these together, the formula that I come up with here is going to be frequency is equal to, I want to pull up my formulas to make sure we have this right. Okay, it is square root my force of tension over mu lambda squared. There it is. That's our, we're going to call this our music formula, right? This is our music formula. This is for standing waves on a string. So hopefully you'll remember the pieces here. This is my tension, this is my linear density, this is my wavelength, the length of my string. When I put all of these together, I can control the frequency of my string. So when I go to number 2 on my homework, you guys are trying to identify what are the different parts, right, of the music formula. So what I want you guys to do is you're going to refer to this formula right here, right? Refer to this formula. And for this one, remember, I have tension, linear density, wavelength, frequency. That's it. Those are the only 4 parts.